Good afternoon, everyone. This is Peter Smallage. I'm the New York State Extension Forester. I want to welcome you to the monthly Forest Connect webinar series. We appreciate those of you that are just joining in. If you would give us your state and your perspective. Are you a woodland owner, forester, blogger? And make sure you send that to everyone, not just the hosts and panelists. We are joined today by a repeat, very popular presenter. Paul Catanzaro is a friend and colleague from University of Massachusetts Amherst, and has been, I don't know how many times, Paul, you've been. Several times. We'll say several. I should have gone in and counted, but I didn't. And but he's going to be talking about his work with Tony D'Amato on restoring old growth forest characteristics. And there were something just shy of 400 people registered. So this is a very popular topic. So Paul, I'm going to mute my microphone and turn it over to you. It's all yours. Thank you for joining us.
Thank you for inviting me. I always love coming and doing these webinars. So I'm very appreciative for you for creating this network of people that are interested in these topics. And thank all of you for taking some time out of your Wednesday afternoon here to learn and talk a little bit about restoring old growth characteristics. As Pete said, up front, I want to acknowledge my collaborator, Tony D'Amato at the University of Vermont. And he and I have been working on this for a number of years. And in fact, some of the numbers I'll show you and some of the topics that we'll talk about come right out of his dissertation work here at UMass Amherst. In fact, when Tony was going to get his PhD, his dissertation topic was identifying the exact location of old growth forests in Massachusetts, and then measuring characteristics of those forests and comparing them against the second growth characteristics of Massachusetts forests. And it was at that point that we started talking about these concepts of restoring old growth characteristics. And it's not, weren't the first ones to do this. Certainly there was work done in the Pacific Northwest in those larger industrial landscapes. Bill Keaton at University of Vermont had been also investigating this concept. And one of the things Tony and I were interested in was taking these concepts and scaling them to a northeastern landscape that is, for the most part, made up of family forest owners with, some larger public lands and land trust lands, et cetera, scattered throughout there. So we actually wrote this publication back in 2007 and had a lot of fun talking about it and describing it and breaking this down for our northeastern landscapes. And we had some comments from people that wanted to try it in terms of how to actually implement this kind of work. So a couple of years later, in 2009, we came out with a more step-by-step guide to address this. And we had a lot of fun with this. This was, something that Tony and I are both passionate about. We love the topic. We think it's very relevant. It was adopted by, some people in the region, but it wasn't until a couple of years ago where this topic of restoring old growth characteristics really started bubbling up more. We were getting more questions about it. We were getting more requests for webinars and things, and I think in part that's due to these conversations that we're all having about the most appropriate role our forests can play in climate change mitigation. Particularly in terms of carbon storage and sequestration. We're certainly all aware that, we're concerned about, biodiversity crisis and crashing populations. And we're also worried about the many challenges that our forests face in terms of forest resilience. So things like emerald ash borer, Asian longhorn beetle, hemlock woolly adelgid, increased droughts, increased significant storm events, intensity and frequency, and so forth. So a number of these topics swirl around or relate to or intersect with this restoring old growth topic. And it was actually Liz Thompson from the Vermont Land Trust that reached out to us and said, hey, what do you two think about updating this publication? And and expanding the scope to New England and New York, and sort of updating it with the current science. And we thought that's a great idea. So Tony and I last spring, worked to update the publication. I'll show a picture of it in my last slide, but that's a little bit about the history of it. And as I said, in 2007, it was a good and interesting idea, but I think its relevance has been increased dramatically in terms of these issues that we're facing. And the larger conversations that are happening at a variety of scales, from global conversations. The United Nations Biodiversity Conference just took place a few months ago in Montreal, talking about the importance of forests and conservation and the peril of biodiversity. We've had ecologists such as E.O. Wilson talk about reserving half of the earth for biodiversity and other human needs. President Biden has come out with a 30 by 30 challenge or policy to try to conserve 30% of lands and ocean by 2030. And more regionally, there are also calls for large landscape conservation in New England. We have this wildlands and woodlands vision, which calls for the permanent protection of woodlands, and then both working and as well as wildland areas. So there continue to be conversations about what is this important role that forests play. How can it be maximized? How can our forests be stewarded in a way that continue to provide the wonderful ecosystem services that they do for us, and how do we steward them in a way that will continue to perpetuate those? And so I think in terms of the challenges that we face, these calls for large scale forest conservation, all, as I said, sort of intersect around this topic, and we felt like it was a good time to update and expand this publication. In order to see where we are now and where we might go in the future, it's important, of course, to look at where we've been. And humans have been interacting with forests for thousands of years. And this is just a reminder that the world certainly didn't start with colonial history, that there is an important history of Native people on the land interacting and engaging with forests through time. And that's an important topic to keep in mind. It's generally considered the fact that indigenous peoples' interactions with the land were within the frame, so to speak, of the historic range of variability in terms of influence on the forests. And so it really isn't until we do get to this colonial period that we see, really dramatic impacts on our forests that have really resulted in the forests that we have today. And so these are famous dioramas from Harvard Forest that show our forests, or an image of what our forests could have looked like, or probably looked like in 1700, largely in what we would call an old growth state. We'll define those terms in a slide or two, to the subsistence farming that happened in 1740 and in that era, to the market-based farming that happened widespread across New England and the Northeast, that largely cleared the forest, leaving pockets of woodlots here and there. And of course, those farms were largely abandoned as the population moved to the Midwest for better farming opportunities, better soil, and so forth. Those forests were largely regenerated to white pine, a species that can spread fairly easily in terms of its light seeded, and has enough of an energy source within the seed that it can get through the sod of mostly pasture and actually regenerate into pine. And then we had this sort of wholesale clearing of white pine for box boards and other products that were going towards people's movement out to the Western US. So part of what I'm hoping to give you in this 30-second history lesson is the reality of the fact that our forests have a long history of this intensive land use history, and have been cleared for the most part, probably twice, giving us the forests that we have today. And so when we talk about what the past extent of what we now call old growth is, the best estimates are somewhere around 90% of our landscapes would have been in this old growth forest condition, and leading to a lot of population and land clearing, as I talked about in that previous slide. And now, having bounced back over the last 100 or so years to the forest that we now see today. So I want to just reinforce this point as if the history lesson isn't enough for us to deduce that our forests are relatively young from an ecological perspective. Here's a study that was done by Ducey et al. In 2013 using the forest inventory and analysis plots demonstrating the age of our forests. And you can see in that graph on the right there that, and again, that was done in 2013. So if you were to, in your mind's eye, take that graph and shift it to the right about 10 years, you would note that our forests are largely around 100 years old, and some of them might be 80 or 90, and some of them might be 110, but there is certainly this large proportion of our forests that are around 100 years old. And so from an ecological perspective, those are still very young forests. I know from a human perspective, we think of 100 years as being very old, but from an ecological perspective, 100 years old for a forest is still quite young, and we're still recovering from that dramatic colonial land use history that I talked about a slide or two ago. And I want to reiterate this point because I've been involved in a number of conversations in the region about the definition of mature forests and ages and so forth. So I want to just put this on an illustration, in terms of making the point. This is adapted from a textbook by Franklin et al. But the reality is our forests are around 100 years old or so, and we really don't know what for the most part how long our trees will live. I mean, we've got trees that are quartered at 400, 500 years old on old growth sites. And so we know it's at least that long, but maybe it's longer. And so the point I want to make with this slide is that we're nowhere near, the old end of the forest spectrum. We're somewhere towards probably the teenager or mid-20s or so kind of age, if you think about it in human terms. I mean, we're around 100 years old. Our forests are still recovering both structurally in terms and species composition from that dramatic, colonial intensive land use history. And we have lots of time to go before our forests are fully developed, sort of fully express themselves in terms of what their natural structure and species composition will be. So again, I'm just reiterating this point of how ecologically young our current forests are. And that's not to cast shade on our forests. They're fantastic. They provide tremendous essential public benefit, ranging from clean water and carbon sequestration storage to biodiversity to spiritual renewal and so forth. So it's not to say they're not providing great benefit, but it is to say that they're nowhere near sort of their final state. So that's a brief description of the past. What about our current forests? As you know, we're a heavily forested region in New York and New England. And, it's estimated that less than 0.1% of the region's forest is actually in old growth. So we've had this huge drop from roughly 90% of our landscapes being in what we now call old growth forest, back then was just forest, to less than 0.1% of our forests being in this condition. So I frankly can't think of another habitat type that has seen such a dramatic loss from 90 to less than a 0.1%. And in New York specifically, having reached out to some colleagues that are actually helping to measure old growth in New York, they suggest that it's probably somewhere around 10,000 acres of old growth. Just to give you an estimate, in Massachusetts, it's more like 1,119 acres. That was a part of Tony's dissertation. And that 10,000 acres of old growth in New York is largely concentrated in the Adirondacks, with other concentrations in the Catskills, and then a smattering of it in other parts of the state. Again, the point of this slide being, we've really, moved from a tremendous amount of old growth forests that our native species would have developed with, to a rather very small percentage of our forests. So I've been using this term old growth. I think I may have even used the term mature. And so I want to clarify for you what I mean, or what Tony and I mean when we're talking about these terms. And this is a conversation that we had between, we put these original definitions in 2007, I think it was. And then as we were updating this publication this past spring, we had to revisit these definitions and decide whether or not we were going to stick with those or move in a different direction. And there are lots of conversations happening now at the national level about what a mature forest means and what the definition is. I've been a part of conversations at various state levels about people introducing legislation about what old growth forest is or what mature forest is. So there are a number of terms and definitions floating around. And I just want to share with you what our definition is, or what I mean today when I'm talking about these terms. When I talk about old growth forests, really talking about those forests that were never directly impacted by that colonial settlement intensive land use, and that is primarily logging and agriculture. So if those forests in the region got through, so to speak, that land use history period, that colonial period, without being harvested in or without being fully clear, then that's an old growth forest. It seems like it's a very logical way to define it, and it's easily interpreted on the ground for the most part. That means that any forest established after that intensive human land use, such as agriculture or logging that we talked about in that colonial land use history period, is what we call second growth forest. In other words, it has grown back since that intensive land use. And I've heard people use, it's third growth, it's fourth growth. We just sort of are sticking with its second growth, meaning to differentiate it from old growth, we call it second growth forest. And as I said, we had a lot of conversations regarding this. These are the definitions that we actually included in the 2000 publication. We decided to stick with those because we think, in terms of assessing a forest and its characteristics, its structural components and so forth, and the values that it's providing, we feel strongly that it's that colonial period, that European settlement, that logging and that agricultural clearing, that really is the differentiation between what forest we have now and what old growth forest would have been. The new change in the publication is the addition of this term old forest. So at some point, presumably, we'll talk a little about this in a few slides, a forest is on a trajectory, hopefully, to restoring its characteristics to a point where it would have the amount of structural components and characteristics that would be similar to an old growth forest. And it's at that point, it doesn't become old growth again, because once it has been cleared or once it's been logged in, you can't recreate that old growth condition. However, you can sort of mimic it, or you can develop the kinds of structures and the kinds of attributes that you would find in an old growth forest. And so to differentiate the fact that there are those forests that are out there, and hopefully there will be more in the future, that can accrue these kinds of characteristics once they've sort of reached that point where they've got, the similar amounts of down wood, similar structural attributes and so forth, that we can call that old forest, to recognize that it's not old growth, but, it does have, a critical mass of those characteristics. And this will change, like the age at which it becomes, old forest will change by forest type and the site index, or the quality of the site and how fast those attributes accrue over time. But, we feel like this is the most tractable and accurate way to sort of define these. So as I go through the rest of the slides, and I'm using these terms old growth and second growth and so forth, this is the meaning that I will attribute to them. So let's talk about old growth forests. And I think when people hear the term old growth forest, as I do, I immediately think of big trees, and certainly that is one very important characteristic of old growth forests. And frankly, it's a characteristic I think we all love. I mean, I know I love walking into a forest and just seeing, really big trees. There's something really special about that. And so, while it is certainly one of the characteristics of an old growth forest, I think we've got to be careful about confusing this quality of the site with the size of the tree. So there's that piece of it. But I think we also need to be very careful about using this as the only determination, because the benefits that come from old growth forests come from a variety of different characteristics that includes old forests, but isn't the only reason they provide this special, unique place. So let's talk a little bit about some of those characteristics, those other characteristics of old growth forests that really make them special and unique. And I'm going to just mention them in this slide, and then in the following few slides, I'm going to break them down and go into more detail. So one of the general characteristics of old growth is that they have a diversity of tree sizes and ages. So it's not even age. It's not just, one cohort of trees. It's a variety of trees, meaning we've got some trees that are very large. And by that, we mean over 20 inches at least. And we do have some trees that are very old, but we also have trees that are young and trees that are of smaller diameters. There is a lot of spatial variability within old growth forests that include, some really areas that are crowded and small with small diameter trees, and some areas that are real well spaced out. I'll show a picture of that. Dead standing trees and dead down logs. Those are obviously important characteristics and very lacking from our current forests. And then one of the other characteristics of old growth is they can have different types of understory plant communities. So let's get into each of those specifically. As I said, there is a diversity of tree sizes. Again, our eye oftentimes just goes to the big trees, and they're really fun and special to see. So I can completely understand that. But if you're going to look at and talk about the characteristics that give us the special benefits that old growth provides, then you got to recognize the fact that it's really a diversity of tree sizes. And one of the themes that I'm going to mention over and over and over again in this presentation is the reason that there is a diversity of tree sizes is because of the exposure of these forests to disturbances through time. So not just a decade or two of disturbance or even just a century of disturbance. These forests have had disturbances to them for centuries. And so these are not static systems. They're very dynamic. So, we'll see a gap come into an old growth forest, and so, a couple of big trees die, and that will create, a patch of light that will regenerate these young, smaller trees. And so over time, as these disturbances happen to the forest, we get the initiation of new cohorts, but we also have trees that survive because disturbances are very rarely fully stand replacing. So we have these big legacy trees that remain in there and continue to grow. So we see this real diversity of tree sizes that give a diversity of environmental conditions within the forest. We have some areas that are very crowded, very shaded. We have some areas that have more space between there, maybe they have some dappled light within them. So that difference in environmental conditions provides different opportunities for different kinds of species to utilize their strategies for survival, which helps with forest resilience. It has a diversity of tree ages, so it's not just sizes. And I know we oftentimes, and for logical and good reason, we attribute tree size and tree age. We sort of connect those together. And certainly there is a relationship there, but that there's not always a relationship. So sometimes big trees can be younger, right? It grows on a good site, or it's been thinned out and it's been grown faster. But there are some characteristics of trees that can only sort of accrue over time. And so there's a diversity of tree ages in old growth forests, including some very old trees. And I've got these three pictures up here to help demonstrate that. When I say to you, what does a red oak look like? I'm guessing for many of you, it's the picture in the middle, right? It's got those silver flat plates. It's got those reddish orange fissures in between. And this is the picture of oak that many of us have in our mind, because as we walk through the landscape, much of our landscape is, 100 years old or so. And so this is where the forest, the trees are at. However, the picture on the left is still red oak, right? But it's just more, it's a younger tree, and it has only primary bark. The second tree has secondary bark, but if you let trees continue to develop over time, they will actually develop a tertiary bark that is different than what we have now. So older trees show their age, and it's important to have this variation within the forest. I've put a little oval circle on there to show you sort of where that bark is starting to slough off, and you're north of that or above that is more traditional, maybe secondary bark, but that tertiary bark below that. And this is where you get differences in individual trees. You'll get, rougher bark, more fissures, more opportunities for insects to hide in there and to utilize that bowl, which means there's more food source for birds and other animals that forage along that bowl. So trees of different ages, and I just want to reiterate this point because I think it's an important one. And ages, right? So some very old trees. So even though we've got some young trees from recent disturbance, we've got some very old trees. That tree on the left is about 350 years old. It's from an old growth forest in Western Massachusetts. The trees in the middle and the right are exhibiting some fantastic features that we would like to see in our forests. That cavity tree on the left with that, in the center with that sugar maple. And then on the right, there are actually a couple different sets of bear claws in that bark, the darker lines being where the bear had climbed up the tree in years past. And so it's sort of darkened, but you can also see, I hope in there, some more light brown lines where the bear has scurried up that tree. Older trees show their age and develop these idiosyncratic characteristics that can be very helpful for wildlife. So we need some of these old trees. Spatial variability. Two different images here. The image on the left is a stem map. So it's actually mapping the concentration of larger trees within that forest, and the darker the color, the higher the concentration of large trees. So we've got some areas within here that that have been subjected to disturbance, but really haven't changed much. So we've got these dark areas, but we also have these very light areas that we've had some disturbances come in and actually create some open conditions by killing some trees. And so what I want you to get from that picture is just the patchiness or the irregularity of these forests due to the periodic disturbances that happens over the centuries. And this picture on the right, I hope, illustrates it and underscores this. This is a LiDAR map. So those trees, those few trees, handful of trees that are in red are the tallest trees. The yellow and orange are the main canopy. And then the blues and greens are trees that are shorter. And again, what I'm hoping you'll gather from here is just the gappiness or the patchiness of these old growth forests. And this is a LiDAR from an old growth forest up in Maine. And I hope you'll see that there are some openings in there, right? There's some gaps in there that are dark blue. And then of course we've got, a lot of that canopy that's in that yellow, orange, and a few red popping out. So these old growth forests have a variety of spatial variability. We've got some areas that are big trees and well spaced, and we've got some areas that have a lot of small stems from recent disturbance, and then of course areas in between. But we want that spatial variability. We like that different kinds of environmental conditions throughout the forest. That provides a lot of great benefit. So another characteristic, of course, is dead wood, both down dead logs as well as standing logs. This is part of Tony's dissertation work. He estimated that there's about 2 to 4 times more dead wood in old growth forests than in our second growth forest. And that's going to vary a little bit by forest type because of densities and shade tolerance and things like that. But the take home from this is twofold. One, that there's a lot more down dead logs in old growth forests, and two, that this dead wood is in a variety of decomposition stages. So on the far left, we've got a tree that was recently knocked over, maybe by a windstorm. And then next to it is a tree that's been there. It's still got some bark on it, but it's definitely starting to rot. The one on the right, on the lower right-hand corner, the bark is sloughed off. We've got moss growing on it. And the one above that is mush. It's just, so we've got different stages of decomposition. There are different species that will utilize those different logs at different time periods. And and I'm just going to plant the seed now, from a forest management perspective, right? If you think of this as a conveyor belt, that there's new trees being input to the forest that are dead, and then over time, nature takes care of the rest and starts decomposing it. But on the front end, we want to make sure that there is enough input of that down dead material that's happening to sort of sustain that system and get to the levels that we would see in an old growth forest. And for those of you that have stacked wood, and I'm guessing most of you on this webinar have stacked wood, a cord of wood is a lot of wood. Having 15 cords of wood per acre is a lot of dead wood. And it's yet another signal about how these forests have been subjected to disturbance, over and over through the centuries. And it's not just this down dead wood, it's dead standing wood, or otherwise known as snags. And in some of Tony's dissertation research, he quantified that it's, again, 2 to 3 times the amount of dead standing trees that were in these old growth systems. And again, once again, same theme, they're in different stages of decay. So the tree on the left was recently snapped off. The tree in the middle has got some nice decay going for it. So it's starting to be infiltrated by fungi and invertebrates and so forth. And the tree on the right has been excavated out by woodpeckers, right? The bark is sloughed off. It's probably getting ready to fall over and be an input to the down dead log, which is great because an entire other new suite of species will utilize that. But again, it's a conveyor belt, if you will, and we've got to make sure that there are enough inputs into that conveyor belt that they're going to see the forest is going to see periodic pulses of that dead wood. And the last characteristic are these late successional plant communities. This is squirrel corn. This is a picture of squirrel corn, just as an example. I think of I love northern hardwood sites. So I think of these spring ephemeral sites and things that are low disturbance sites. A lot of these are very slow moving. There might be ant dispersed seed types of species, and so it takes undisturbed conditions for a long time for these plant communities to build up. And so you tend to see different kinds of understory plant communities in these areas. And again, because our forests are ecologically young, we're not seeing these in many or most of our forests. So that's just sort of a breakdown of the characteristics of old growth forests. And so I think it's logical to ask the question, so why is that important? Why are those various characteristics important? I think there are a number of reasons, wildlife being, one of the big ones. And frankly speaking, when we started this in 2007, it had a real biodiversity kind of angle to it or perspective to it. While there's not a charismatic, obligate late successional old growth species in the Northeast, like there is the spotted owl in the Pacific Northwest that you're all probably familiar with, there are a number of species, certain types of fungi and lichens and so forth that need this kind of structure. These areas tend to be source populations, meaning these are areas that are producing more individuals than the area can actually hold. And so these are areas where fledglings and other young species individuals will move out and repopulate other areas. So when we look at population dynamics across a landscape, these source populations are very important to repopulating areas that may have blinked out from a disease or some sort of event. They provide, because of this complex structure, this diversity in young, medium and old trees and small trees and medium trees and big trees, and spatial variability, the heterogeneity across both vertically and horizontally, they provide, it's a very niche rich environment, right? There's a lot of opportunities for wildlife to partition various parts of that ecosystem and utilize that for their needs. These areas are also very important, I would suggest, as stepping stones across the landscape. So particularly for species that don't, like birds that migrate, thousands of miles, species like fungi and other flora within the system, don't move very far, very fast. So having some of these areas within the landscape that allows the movement of these species, particularly to adjust to climate change, is very important. And I know when we talk about biodiversity, we oftentimes talk about these, big, beautiful species. But let's not forget that the engines oftentimes of our forest ecosystems are these smaller fungi and so forth. So having a diversity of tree species, down dead logs and so forth is a great way to provide for their growth and existence. As I said, as we started this in 2007, wildlife was a main focus, but climate change has really, again, this topic I think intersects very well with climate change. These areas that have lots of these characteristics are areas that are likely going to be the areas of highest carbon storage. So as big trees, diverse layers, lots of dead wood, lots of carbon in the soil and so forth. So from a climate change perspective, these systems tend to be like the Gringotts Bank, for you Harry Potter fans out there, of carbon storage, right? They're holding lots of great carbon. And they're also tend to be very resilient places because of that structural complexity, because there's a lot of redundancy in the system, because there is a lot of different environmental conditions that support a variety of species, which then have a variety or a diversity, if you will, of regeneration pathways. So if the forest is disturbed, which inevitably is going to be, there's another species to take its place, or there's a sprout, or there's an opportunity for the seed bank to sprout. So there are lots of different ways for the forest, in essence, to be nimble and to be dynamic and to adjust to it. So from a resilience perspective, I think this lack of old growth characteristics is an important point to make and to restore. And then I would just say to you, from a scientific perspective, this baseline, these provide baseline conditions. Like what would happen if our forests if we didn't touch them? Or what would happen if our forests if we didn't encourage these kinds of structures? So I think that's an important thing to know, particularly as we move forward with a seemingly ever increasing amount of invasive plants and insects and challenges and an uncertain climate. Having some of these areas I think is essential. And then the last thing I'll say is just, we don't know what we don't know. And I think in the last few decades, I think we've seen an explosion of knowledge in forest ecology and applied ecology. However, we still don't know what we don't know. And so we need to be very humble. And I think these areas can help us be humble. So I used to put this slide at the end of this presentation because every time I talk about this presentation, I think about this slide, or I think about this quote from Leopold, and that we're missing, but I've decided to move it up into the middle of the presentation because I think it's so relevant. We need to keep every cog and wheel in our forests, I would suggest to you. And we don't have some of our cogs and wheels. We don't have, because they're ecologically young, we're still recovering from that colonial land use, we don't have all of the parts to the forest. And so I think particularly as we start talking about climate change and invasive plants and insects and all the challenges we face, I think we want these forests to have the benefit of being fully expressed, of having all of their parts. And so I think this is, to me, this is a real driver for me in terms of the work that I'm doing with this. The other thing that I want to point out with Leopold is of course, that land ethic that he's so well known for, and in our relationship to the forest and what that means. And by no means, is Leopold the first or only one to talk about a different relationship with our forests. And so I've been reading Braiding Sweetgrass, and we have a Women on the Land network here in Massachusetts that's had a book club that's been talking about this. And so I just want to point out that Leopold's not as I said, the first or only one to talk about this relationship with nature or with our forests, and this concept of reciprocity that Kimmerer talks about, to me, really intersects well with this restoration of these missing parts. And we expect a lot from our forests, and to me, part of that reciprocity is restoring that. So what are some of the strategies? We've gone from 90% to 0.1% or less within our landscapes. It's a huge, in fact, in some ways it couldn't get much bigger of a drop. So what are the ways to restore some of these characteristics? And again, we can't, and people always hear this wrong somehow. I'm not suggesting we can recreate old growth forests, but there are ways we can help cultivate or bring some of these characteristics back. And of course, the first way is just through passive management. Let nature take its course. Let nature continue to grow. Let that forest continue to grow and develop. Trees will get bigger. Some trees will die. That'll create gaps in the canopy in our very uniform, even age forests. And that'll help with the diversification of the ages and sizes. That'll help with the heterogeneity and that spatial variability. It'll help with the dead wood. All of that will help in time, and it will be disturbance that will be the driver of that. So we can, in part, just have faith that our forest will develop that way over time. And if you are going to take that approach, I get the question, should I salvage? And while these disturbances are the driver of that change in our forests, and disturbance has always been the driver of change in our forests, it can look really messy. It can, people don't like the look of this. But even though it looks messy or it looks damaged, this is how our forests have evolved. And this is the kind of thing, the kind of action that's actually going to lead to more of this restoration. So if you are managing a property, or you do own land as a landowner or an NGO or land trust or a municipality, if you do take this passive approach, then let nature do its thing. There might be times you've got to intervene out of safety reasons or get trees out of trails, but to the extent you can leave as much unsalvaged as possible, you're going to be moving that forest and cultivating those characteristics. So when we look at how fast trees grow, and we look at where our current forests are at, around 100 years old, if we take this approach, then we will get to that large tree benchmark, which is influential because, it's A, one of the characteristics of a forest, but B, leads to the big dead wood, it's standing, the big dead down wood, etc. So that large tree benchmark is important. If we let our forest grow and develop through time, we will see, an accrual of large trees in about 100 years that mimics or is starting to get in the ballpark of old growth forests in terms of what we've measured in current old growth forests. And then, of course, after that, it just continues to grow and develop through time. But it'll take roughly about 100 years, as I said, ecologically young forests. I want to make this point, though, because there have been a lot of conversation, some of it very heated conversation about, what is the best strategy for our forests, and should we just be taking a hands-off approach? It is, this is the approach that would give, in most cases, the most amount of carbon storage. But I just want to be cautious with this, because it may be that not all of our forests, if let go, will get to this point. In other words, because of invasive plants in particular, or other challenges, it may be that our forests don't develop in the way that we hope they'll develop, that, we have now introduced a different dynamic in our forests. And I have ultimate faith in our forests. However, it could be that it might take, centuries for our forest to overcome Japanese barberry and get the forest to a point that it's at a condition that would be comparable to old growth forests. So I don't know or I do not think we can sort of just take a hands-off approach on all sites and have the expectation that they will eventually get to that old growth state. It's one thing that I think you've got to consider when you're citing this passive approach. The other approach, of course, would be an active management approach. And I'm just going to step through a couple of things here. You can, if one of the characteristics is diversifying tree size and spatial variation, then when you're looking at active management, combine the removals of individual trees and gaps. So in other words, we want to create that patchiness. We want to leave a high proportion of mature trees, but we want to use regeneration systems, silvicultural systems that are not even age and taking everything out at once. We want to keep that, we want to promote or keep that patchiness or that gappiness. And we can do that by using, some standard silvicultural systems and applying those. If we want to increase tree size, this is what forestry's been doing for centuries. It's been controlling density, concentrating growth on those individuals that we want to grow faster and actually growing them out. We can actually designate some trees as legacy trees or patches of legacy trees as patch reserves and actually just leave them standing. Let them die naturally, let them decay standing and then, fall to the ground. So we can increase the amount of stand variation and dead standing trees by designating these reserves and individual trees. Of course, by doing this, we're also increasing the amount of down dead logs. For those of you taking a complementary approach, restoring old growth and timber, these down dead logs can be unacceptable growing stock. It doesn't have to be the best timber out there. You can still complement some of this traditional management and recruit some of these characteristics, and they can, again, creating some patch reserves, some low disturbance or no disturbance areas to help promote some of these low disturbance plant species. So just to help point this out, this is that graphic that I showed you about the patchiness or variability across old growth stands. If we were to use the variable density thinning approach, then what we could do is use, designate 20% of that area in skips, meaning patch reserves, oftentimes around areas that already have existing structure or high resource value areas like vernal pool complexes or wetlands, or areas that are culturally significant, and then regenerate 20% of that gap. So creating some patches in there that would help diversify the species sizes and ages within that forest, and then thinning in the matrix in between. So increasing that size. Again, diversifying the environmental variability. That's some areas that'll be shady, some that'll be sunny, some that'll be both. So trying to incorporate, more of this variability within our silviculture. So these are just some sketches that the designer helped me put together. She almost killed me because I had, 452 different versions of this. But sometimes, to be honest, it can be hard to capture through photographs the exact kind of message I'm trying to communicate, because forests are complex and sometimes it just looks like a wall of green. So we've oversimplified it in this cartoonish type of diagram. If you think about this as a typical sort of second growth forest, about 100 years old, it's very even aged because the forest grew up at the same time. It's got a very uniform canopy, not much in the understory, not a lot of dead wood. On the far right, you can see that there has been some disturbance. Our forests at 100 years old are starting to naturally, develop these size trees and patches and so forth. So we're sort of on the front end of this, and we're starting to see it. But if you were to apply some of these treatments that we're talking about, for example, in that gap that's labeled AB, maybe you put in a 1/4 to 1/3 acre gap. In C, maybe you thin out between the trees to help increase the growth rates of those trees. You leave some of the trees on the ground, as can be seen in B, to increase the dead wood. And then that area on the far right, labeled as D, that's already seeing some accrual of these old growth characteristics, maybe you name as a patch reserve. So you can go in and intervene in an active management way to help expedite or speed up that clock. And within 15 years or so, you've got a response in that gap. So now we've got trees that are young, that are smaller diameter, complemented by these larger trees in the middle with a different environmental condition, with that patch reserve starting to develop through time, more dead wood on the ground. In over 30 years, we've got more regeneration starting. We've got the further diversification of the environmental condition in that horizontal heterogeneity, and so forth. So hopefully you can see in these cartoonish diagrams that you can apply some of these strategies and recruit or help cultivate some of these characteristics. And if we use, for example, 2 or 3 crown thinnings within that forest, then when we take a look at the response rates of trees to things like crown thinnings, then we can see that we actually estimate that you can increase, or excuse me, you can decrease the amount of time it takes to get to that large tree benchmark. So instead of waiting 100 years, we feel like you can get to that large tree benchmark in about 50 years. So, cut it in half, if you will, to help expedite the accumulation of these old growth characteristics. I want to be clear that a diversity of benefits, and we expect a lot from our forests, a diversity of benefits requires a diversity of approaches. And here's some data from the Cornell Lab of Ornithology about declining in bird populations. I don't want you to walk away thinking that this is the one strategy and that I'm promoting and that, there's a cookie cutter method to this. We need a variety of intensities across a variety of sites across the landscape to meet all of our needs. And that's both wildlife biodiversity, but also, I'm working with some colleagues right now. We're finishing a draft of a publication looking at the production and consumption of New England. And as you can see, the consumption rates in New England, with the exception of Maine, far outweigh, our removals in these states. And so there's an ethical question regarding where we're getting our wood from and what those impacts are from an environmental perspective, carbon perspective, et cetera. So we need a variety of approaches across the landscape to give us a variety of benefits. And that's why I think it's important to communicate that I guess we don't see these strategies as being a cookie cutter. There's not one way to do this. I think it's better to think of these as a gradient, so that if you are really interested, if restoring old growth characteristics is your primary objective, then I think you're keeping more in the forest, like you're keeping 25 to 50% of your trees as legacy trees and letting them grow old and die and large and so forth. However, on the right-hand side of the gradient, it might be just a related objective. It's nice, you want to add to it, but it's not, it's not your primary or your complementary objective. It doesn't rank that high. So I would suggest, even just leaving a few legacy trees per acre and implementing, the forester recommended silviculture, you can still help, at a landscape level, recruit these characteristics across the landscape. So, I would encourage you to think of this as a gradient, that you can do what you normally do with, some additions, or you can go whole hog and really go after it if it's a primary objective, and lots in between. And we have to consider the fact that there are some trade-offs to this gradient, right? So one being the species we're regenerating, and that's becoming more and more important and more of a challenge with deer herbivory, moose herbivory, invasive plants, and so forth. Recognize that if you're on the left side of the gradient, and it's a real primary, that because you're keeping more and creating smaller gaps, that you're likely going to regenerate shade-tolerant species. And if you're on the right side, you have the opportunity to regenerate more shade-intolerant species. So you have to match sort of that scale or that gradient with also, importantly, your regeneration goals. And much of the work on restoring old growth has been focused on structural attributes, and I've spent most of my time talking about structural attributes, but we have to make sure we're meeting our species regeneration goals as well as recognizing that further right on the scale, it's less, it's more timber revenue, more early successional habitat, more contribution to the local wood economy, and further left you go on the scale, you've got more on-site carbon, more late successional habitat. So how do you balance that with your landowner's goals and what the site will give you? So let's talk about that. Let's talk about, our classic New York, New England landscape that's made up of a patchwork of owners, right? So we've got public lands, we've got some municipal and NGO lands, but we've got this whole matrix of family forest owners. And if each one of these columns was a separate property, I hope you can see, or what I want to encourage you to consider is, you can apply these strategies in a gradient and all of it will add up over time. So on the far right, if you were interested in regenerating, black cherry or other shade intolerant or even mid-tolerant species, you can still open the stand up, but maintain some patch reserves and some legacy trees in there. That biological legacy that's carrying through from one generation of the forest to the next. And on the left, if you are more interested in shade mid-tolerant or even tolerant species, you can apply these strategies, maintaining those dark green patch reserves, just maintaining more of those, keeping more in the stand. And you can apply sort of this passive approach. So across the landscape, you've got these stepping stones of structure, even though you're working, in different ways, regenerating different species. So, it drives this question of passive or active. We need both across the landscape. And I think the mistake that often gets made is, one is better than the other, as opposed to thinking them as part of the same complementary strategy. So if different ownerships were doing it in different ways across the landscape, it would all add up. And so it doesn't have to be all or nothing for your ownership. You can do a passive approach in part of the landscape, a part of your property, and an active in others. Or if you own multiple parcels, you could do passive on one and active on the other. So over time, across the landscape, as people are doing different things at different scales, hopefully it adds up. And so from a resilience perspective, and from a biodiversity perspective, what we want is heterogeneity across the landscape. We want different age classes. We want different species. We want the resilience of that. We don't want all of our eggs in the one basket, and we want all of the habitats represented. However, they can be woven together, if you will, with these structural elements, with these old growth characteristics, by leaving these patch reserves, single tree, legacy trees, deadwood, and all of these characteristics. So even if it's different approaches, if they're still maintaining those characteristics within that property or helping to recruit them across the landscape, will have these resilient, diverse properties. I'm coming to the last slide or two here. I just want to be clear that, unlike early successional habitat, which can take, days or weeks to create, this is going to take decades or centuries. So pairing this kind of work with land protection is absolutely essential in terms of making sure that the forest has time to develop fully. And I'll just close with this, recognize that we've, had this huge jump from 90% to, 0.1% or so of our landscape, that there are strategies, both passive and active, that you can take to restore these characteristics. We need both on the landscape. You can mix and match these, as I was just talking about, to provide this wonderful benefit. You can look at this, or please look at this as a gradient. It's not cookie cutter. It should be paired with, or can be paired with, other goals and objectives. Because of the amount of parcellation in our landscape, taking that landscape perspective is really important. How does your land fit into the broader landscape, and how can you contribute, even in a small way, to accruing these over a larger area? And the importance of permanent land protection for not only restoring old growth characteristics, but for all of the wonderful benefits that our forests provide. So there's a picture of the publication. If you're interested in copies, I'm happy to mail you copies, however many you want. You can just reach out to me. And I haven't left a ton of time for questions, Pete. For that, I apologize, but I'm happy to stick around and answer questions people have. And thank you very much for your time. And Pete, thank you for hosting.
Paul, thank you for presenting. This was fabulous. And it's really fun. I really enjoyed the way you presented it. So it's the fact that you wove it into this bigger picture thinking of, blending it with landowners that have different perspectives, and some of them want no stumps, and some of them need to make some money. And then we're also part of a wood-based economy. And so it's just like, it was really, 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 really well put together. So I appreciate
Thanks,
that.
Pete. I appreciate it.
So there's been some really good conversations going on. Some of them are like kind of side conversations. So how do you want me to go through questions? Can you see the questions?
That'd be great. And while you're doing that, I had a request for a link to the publication, which I should have been prepared with. So while you ask,
I've put it in there twice, and I just put it in again. So I went
Thank
to
you,
your
Pete.
web,
You're a master.
what? Yeah, it's like, it's tough stuff. I go Google restoring old growth characteristics. As soon as I had the title, it was easy. So,
Good.
all right.
So I guess serve up any questions that you'd like. Maybe that's
Okay.
the best.
And I will, so I'll encourage everybody um, to look at the conversation. There is a kind of a sidebar conversation about, uh, which forests and trees sequestered the most carbon, since that's kind of on the tangent to the old growth, the practice of creating old growth strategies. I'm not going to, I mean, if Paul wants to comment on that, he certainly can, but we'll just maybe leave that as a sidebar conversation. So Jake was asking about, and this was early on, 1218, asked a question about, if old growth is typically limited or mostly going to be associated with poor soils or difficult to access areas. I mean, where does
You
it?
know that. Oh, sorry.
No, yeah, I think you got it.
Yeah. It's a great question, and you're spot on, right? If it could have gotten lodged, or if it would have made a good pasture, it probably was. And so, in some ways, we use these old growth areas as benchmarks, as we should, in areas to better understand what a forest would be like if we didn't touch it. But we also have to recognize that almost by definition, these areas are pretty unique among themselves, because they are on these sites that are maybe fairly extreme, is a way to put that. So to me, that's one of the reasons why, having a system of wildlands and reserves, or having some of these sites that are actively managed for restoring old growth characteristics can help us better learn what would a regular oak pine site be like, or what would a more standard northern hardwood site be like. So we learn what we can from these existing old growth areas, with the grain of salt, or the recognition that they're not necessarily typical sites.
Okay. Eli asked early on, and you kind of addressed this when you got into looking at things like the picture of the barberry, but Eli's asking about how deer overpopulation and deer browsing is going to impact transitioning to old forests. And
Yeah, this is a part of the comment in regard to, can we just take a hands-off approach and assume it's going to get there? And I'm just not convinced. I think there are certainly some sites, absolutely, that we can and should do that. But if you're in an area that is devoid of regeneration because of high deer densities, I don't know if we're going to get there. And if you're in an area where invasive plants are out competing, and you just have thickets of whether it be native mountain laurel or invasive plants, bittersweet or barberry, or name your favorite invasive, I don't know if we're going to get there from here. And so the idea of just taking a hands-off approach in all areas, forests will be fine without us. Forests don't need us, we need forests. And so I think the bigger question is, will forests develop as we expect them or hope they will, or do we need to help by intervening and controlling a deer herd, or controlling invasive plants, and either then letting nature take it from there, in other words, set it and forget it, get it on the right successional trajectory and let it go and give it time, or maybe we continue to work with that site. But the one of the pictures I showed in that slide about citing passive approach was sent to me by a consulting forester not long ago, and it was this email of this picture, and it just basically said, what do I do with this? Like there's invasives everywhere, there's mountain laurel everywhere, and he was sort of like shrugging, like, what the heck do I do? So I think we've got to be very intentional, and this is what foresters are great at: what's on the property, what's its landscape context, here's the full range of tools in the toolbox, how do I get from A to B?
okay. Justin was raising the observation. So this is when you're defining old growth, the terminology, and made the observation about Krumholtz vegetation at high elevations, old trees, very small, relative, I mean, compared. So does that I mean, there's a
Yeah,
question, is that
that.
also old forest? It's just like it's a really small part of the old growth that's out there, which is already a small part of the forest.
Yeah, yeah, no, excellent point. Thank you. And I'm mistaken for not having addressed that. And we do have a box in the publication that talks about, I guess by definition, all of old growth is unusual, but unusual old growth, which is these areas that might be on the top of a mountain or in a bog, or those areas that are just might have 5-inch spruce that's hundreds of years old. And so these are absolutely areas of old growth. And I think what the ultimate goal is having areas on a diversity of sites that are leading towards a diversity of forest types. So we want, some old growth areas up on top of ridges. We want it mid slope. We want it in rich, cove areas. And because each of those will grow different vegetation over time, have different kinds of habitats. So these are absolutely a part of, the old growth definition. And I apologize for not being more direct about that.
Okay, well, we didn't want you to come and just read the book to us though either, Paul.
There you go. There you go.
But it's a really good point.
Yes.
Yeah,
and again, and sorry, I just want to, and again, this gets to like even all of our bias, but certainly I have a bias towards big trees, right? We see big trees, and I know people in the public, they're like, oh, that's a big tree, it's old growth. It might be a big tree, but it's not old growth. Maybe it is, but age and size don't always, aren't always directly related. So we've got to be conscious of that. And it's these other characteristics, diversity of structure, heterogeneity, different sizes that really give lots of the benefits. So we want to be conscious of that.
Still with the terminology, Nick was asking about the term primary forest, differentiating on the fact that there may not have been human activities, but yet natural disturbances that removed some of, so like the big trees aren't there. They could have been blown down, for example. And so is there a differentiation of these non-human impacted areas that maybe don't have some of the characteristics that you were describing as old growth?
So I would put what you just described, if disturbance is the driver of change, I would put that solidly in the old growth category. That these are dynamic. They're not just stands of big, huge, trees that never change. And as soon as they change through disturbance, they're no longer old growth. They're still old growth. Disturbance is a part of that. It just, they may have had a big wind event and lots of big trees are down, but it's still old growth. It still has those characteristics. What I would consider primary forest would be forest that's never been cleared for agriculture, but has had some amount of maybe, harvesting in there. So for example, it would not be unusual, in fact, all of these farmsteads in New England would have had a wood lot, right? You needed to get firewood somewhere, you needed fence posts, and you needed stuff for building materials. So, there are these wood lots that aren't old growth because they've been harvested in. However, they haven't been cleared for agriculture. So to me, that's where I've seen that definition of primary, that they've always been forest, but it's not old growth. And they would, to me, I think they probably have some of the combination of those characteristics. In other words, if it hasn't been cleared, there's probably pit mound topography. The ecosystem within the soil is probably intact or mostly intact because it hasn't been cleared. So, so to me, that's where I've heard the term primary.
Okay. And there are, just for the people that are listening, some of these questions got answered later, so I'm just going past them. So Justin is so you're talking about 15 cords of deadwood on the ground per acre in old growth. Justin is wondering if that estimate has perhaps changed over time as we've had an influx of native and non-native pests killing trees, and maybe wondering if in centuries prior there may have been less. I mean, who knows, right? Because Tony didn't go back in time, but how might that change over time? How variable is that across space? So maybe
Yeah,
if you could.
yeah, I think as I mentioned, so he was working primarily in hemlock hardwood stands. So in oak stands that might be lower, just as a baseline, that might be lower. So there's some variability within forest type, irregardless of current challenges. But I would say that, Tony's numbers are probably pretty representative, at least of recent history, because there wasn't, a lot when he's old, man. So he was doing this, whatever it was, 20 years ago, before EAB and ALB and things. So I think that's probably my gut is that's probably a realistic of recent history. I think the bigger question to me is what will those amounts be in the future, now that we're expected to, and I think starting to see more frequent and more intense wind events, storm events, weather events that could certainly kill trees and will, more invasive insects, as you suggest, and things. So I don't know what that would be. I'm guessing it's going to speed things up, which might help structurally. So maybe there will be more dead wood in the future, but it's as you pull the thread, it's connected to everything else. So as those trees are dying, are new trees regenerating, or are existing, advanced regeneration taking over, and how will that play out over time with the future inputs of wood? So I think that's a TBD. I think for now, we've put into the publication some tables. We've tried to establish some targets for foresters or other land managers or landowners to give you a sense of, by forest type, what you might, when you're there, so to speak, not that you're ever there fully, but or totally and you stop, but like, what are these ballparks of volumes? But I think you're right. I think with more disturbance and more invasives, maybe there will be more, more downwoody debris. The bottom line is, I think the take home is we're lacking. We're lacking a lot. What the exact number ultimately is probably a moving target, but focusing on morticulture, right? Focusing on dead wood and being the driver, or making sure you're planning for inputs of this dead wood, either by leaving more on the floor, intentionally felling it and leaving it, or leaving legacy trees that eventually die, be that input to ensure that there will be these pulses.
Okay, so that's a good segue to another question, and it's probably so the question is about other forest types. And so you just mentioned there, the book gets into some detail about some of these other forest types. There is the question dealt with kind of fire adapted systems.
Mm.
Was fire, I know virtually nothing about fire. My sense is that it's probably patchy, at least in the East. And so it's not going to be all consuming like a fireplace is. But what happens with the snags, with downed woody debris? How does fire or other, how does old growth, let's just broaden it. How does old growth look as you get into other kind of forest types?
Yeah, so it's going to have its own unique characteristics. Like hemlock's going to be different than northern hardwood, and that certainly applies to systems like pitch pine scrub oak that are fire-driven systems. So the amount of dead wood in those fire-driven systems is going to be less than it would in a hemlock forest, because there's going to be just less. You get those savanna-like systems that's going to just contribute less down wood because there's less trees standing. And you're going to have maybe a more frequent fire system that's going to burn things on the ground. So that's not to say that those aren't old growth, right? So just because it's changing, just because there's some disturbance, in this case fire, doesn't mean that it's not old growth. It might have different targets, so to speak, or it might have different characteristics structurally that you could measure. But certainly those are old growth systems. Each system, has its sort of old growth targets structurally. So it will change system to system, and certainly that's sort of a big change. The difference between, hemlock and northern hardwood is probably smaller than hemlock to pitch pine scrub oak, but those are old growth systems. The disturbance is a part of them. That's the driver.
Okay. So now we're getting questions closer to when you're getting into some of the management strategies, Bruce was thinking about putting some patches in, but was worried that he's going to get dominance by honeysuckle and hay-scented fern, and there's some resistance to using herbicides. It's a multi-family ownership, and are there other options? So how do you what do you know of? I'm not sure what I would offer up, so maybe you've got a solution that would.
I wish I had a silver bullet, but you're thinking, so I don't have I'm sorry that I don't have a silver bullet for this, but I would encourage you to, you're thinking along the right lines, right? If you're going to put a patch in, if you're going to open up the sunlight, if you've already got hay scented or an invasive plant species established, you're just going to exacerbate. It's like a gas on a fire. So you whether it's restoring old growth characteristics or just more standard silviculture, I think you've got to deal with that before you start into that canopy. And again, that's why I reiterate. I just don't, I don't think we can take a hands-off approach in all sites and expect that it's going to develop over time into these, old forests. So I'm sorry to disappoint. I wish I had a better answer.
Yeah, no, it's tough. I don't. So, scrolling down through lots of accolades about how great you did. And then someone wants your email, which is paulcat@umass.edu. Is that right?
Yes, I'll put it in.
All right, I just did.
Yeah.
Okay, I did. I was typing that while you were talking about other stuff.
Pete, can I offer a comment? Just because I love having a group of foresters and land managers and landowners.
No, absolutely.
If anybody decides to apply any of these strategies in whatever intensity, boy, I'd love to hear about it, or I'd love to get a photo or a quick email or anything that you've got the time to do. Because that's what foresters are so great at, is sort of the art of the implementation. Every site's different, every landscape is different. I'd love to know and learn from you as to how what's working and maybe as important what's not working with some of these strategies.
Okay.
Ooh, Toby Alexander, I thought we put a date on it. I'm sorry if we didn't. But it would have been 2022 as a publication date.
So Damien's wondering about, is there concern about developing old growth conditions with the loss of keystone species like American chestnut?
Gosh, I would hope that's a complementary effort since they were a keystone species in terms of restoring the cogs and wheels. That's certainly a cog and a wheel that love to have back in the forest. So I think these strategies can be should be and are highly complementary of other initiatives. If you're interested in restoring chestnut, that would be fantastic. In order to do that, I'm guessing in the natural setting, you're going to have to create some gaps, quarter acre, third acre gaps, and maybe do some planting, of a new strain of chestnut. So all of that will diversify size, age, species, amount of light across the forest. So I see that as highly complementary in terms of, the approach.
Okay. James picked up on your comments about kind of managing across ownerships, says managing for old growth and private land will require cooperation among multiple generations and multiple landowners. What methods can be used to encourage or require this cooperation?
Boy, if I had the answer to that one, that's been something we've talked about, as foresters, at least in the Eastern US, for decades. And there's been lots of conversation and study on that. I wish I knew. I think.
Well, so breaking it down, you've done a lot of work, I know, with the, your land, your legacy. So so on a property, how do you convey And if you're starting, even if you're starting with an active management, you've got a 50-year window. That's a couple, maybe a couple of generations. So how do you
Oh, I'm
work that?
sorry. I took that as across the landscape, like
Well,
between.
so is both. So is both. So I was
Oh,
gonna,
okay.
I was breaking it down, and
Okay.
now I'm breaking it down just because I know you
Okay.
know
I
the answer to.
appreciate it,
I
Pete.
know you know
Because
the answer to this one, or you've got a lot of thought about it. So
yeah, it's so critical. I mean, I think even if it's not, if you're not focused on restoring old growth characteristics, I would suggest to you that the tide that rises all boats, if that's the right phrase, is maintaining forest as forest. You know, whether we're talking about carbon or biodiversity or invasives, climate change, it is paramount that we maintain enough forest cover to still, you know, reap these wonderful benefits. And, you know, when the average age of a landowner is close to 65, and we're in the middle of the biggest intergenerational transfer of land our country has ever seen, you know, that's why I spent a ton of time on this topic and helping families make decisions. So I think formalizing the decision, you know, having the conversation in the family, formalizing the decision, and that can be done in a will, a trust. It can be done, and that will help control the ownership of the land, and you can dictate that through those legal instruments. But if you also want to make sure it stays forest, then you need a tool like a conservation easement or a conservation restriction. And you can talk to your local land trust about what your options are for that. But I would highly encourage you on any property that's privately owned to engage in that kind of planning. The sooner you do it, the more options you have. However, it's extremely important, you know, if you want to pursue this restoring old growth, because it does take decades or centuries to see it, you know, play out. So you've got to pair it, you know, the strategy with this conservation-based estate planning. And then, so that's within the property. And then across the property, you know, there have been lots of, you know, to me, the things that have worked best have been neighborhoods, if you will, of landowners, you know, getting together that have a relationship, and it doesn't even have to be, you know, you do this over there and I'm going to do this next to you. I mean, it can be, and you can reach great benefit by pairing your management, but even communicating with one another about what your goals are or your strategies are can be very, very effective. So cooperation can exist at a variety of scales, from very formal to very informal, having a chat with your neighbor and everything in between. I think there are opportunities, and this is what I've started talking to some of our land trust and state agency folks about, of taking some of these areas, like in Massachusetts, we've got a reserve system. What are the opportunities to contact, you know, landowners around some of these features in the landscape and see if they're interested in applying some of these strategies, or, you know, around a land trust property, or frankly, you know, there are some of the state forests that are reserve in part and you know, managed woodlot in other parts. How can we apply these strategies near or around reserves that will help complement those? So I think it can be an opportunity to rally people together and say, within a landscape, hey, we want to increase some of this. We've already got a good start because land trust acts as, you know, a reserve, or state forest Y, or I live in the Adirondacks, you know, and there are areas that are a preserve. How would you then, around that landscape, reach out to people and help them reach their goals, and while doing that, also incorporate some of these strategies?
okay. Do you have thoughts about assisted migration into these old growth forests?
Yeah, you know, it's sort of it's a whole new world. I think we want to combine these strategies with other complementary, you know, with other goals that the landowner has. So if the landowner is encouraging, you know, by planting and you know, moving some species up, I think it's compatible. You know, again, remember the idea. We're trying to diversify structure. We're trying to diversify horizontal and vertical, you know, canopy layers and structure. We want old trees and medium trees and small trees. We want old trees and young trees. We want a diversity of species, and we want those species to be well adapted to the site and well adapted to future conditions. That's, you know, that vigor is what's going to give us the most benefit, both from a carbon sequestration, storage, biodiversity perspective, because it'll be long lived and it will help that site be resilient because it has a diversity of species. So again, I think there's a compatibility to this. that would mesh well.
Okay. And you have, I think, answered all the questions, Paul. I appreciate that. So
Outstanding.
there's still some conversation on about carbon. Do you want are you interested in jumping into that at all, or leave that leave that as a sidebar?
Well, I guess I didn't see the conversation, but just, as I said, these areas are likely going to be the areas that store the most carbon. And I would say my perspective is we can't, or we shouldn't, narrow the focus of our forest benefits down to one product. We tried that with wood products, right? We have a century of getting the cutout and sustainable yield and all of those things, and we lost or we diminished, the other values, wonderful values that forests can provide. And I think over the last few decades, we've recognized that and have very much tried to diversify and support the many benefits that forests provide. And now I sort of see us taking a step back in some ways and saying, well, we're going to go all in with carbon. And I've had people say, the biodiversity doesn't matter because we're in a climate crisis. We're going to go full on with carbon. And I guess I would respond to that by saying, I think we're going to be best off by encouraging forests that have all of their parts, that are fully functioning, that express themselves fully, and that therefore will provide a diversity of benefits through time. And we want to not only take a look at, and I think so often these conversations focus on the stand level or the property level, but I think it's really important to step back and look at the landscape level. If we really want carbon, biodiversity, and all of these benefits, we have to have a diversity of approaches across the landscape. We need different age classes. Remember, different disturbances affect the forest differently. Overstory is more affected by wind disturbance and ice, for example, than the understory is more disturbed by fire. So we want different, ash is affected by EAB, hemlock is affected by HWA. We want different species, different age classes across the forest, and we want the forest to have all their parts. To me, that is the approach that will give us the most biodiversity, the most benefit, and in the long term, the best carbon benefit.
Okay. So here's one more question. This will be the last one.
Yeah, it's fine. I'm a geek, Pete. I would do this
I know
all day.
you. I know you are. That's why and we're joined by a lot of other geeks, like almost half of them. I know it. This is good. This is good. So if old growth is a goal, this is Russell, old growth is a goal for mass forest reserves, what would you recommend if some of these reserves were not progressing towards old growth? Should active management be overlaid on that? So I'm guessing that the mass forest reserves have a no management policy.
Yes.
And if they're not progressing towards old growth, what should somebody do?
So I actually sit on the Forest Reserve Science Advisory Committee with our reserves, and this conversation has come up. I will just be clear that again, they wouldn't move towards old growth. They would move towards old forest, because once we've lost that old growth condition, we can't get it back, but we can get the structures back. So that's me being neurotic about definitions. But I would say, to me, I think letting them go is an important experiment. I think one of the reasons we want these reserves is because we want to see what happens if you do nothing. And so I think from the scientific perspective and from the applied ecology and management perspective, we need some areas in the landscape that are like that. And we want to know if it takes 50 years to get around barberry, or does it take 150, or does it ever get around barberry? And so I think patience is key with these reserve areas, and just not overreacting, letting them do their thing. Now, that's not the answer I would give necessarily on private land or on other areas that are being actively managed. But for these areas that have been set up for reserves, let's let them play out. Let's complement the management in other parts of the landscape. But I think it's good and appropriate to let it all play out.
Okay. Justin would like to know if there's a portion of old forest that's a reasonable target, a
That's
range.
a
So
great question. Yeah, great question. At the landscape level or at the property or maybe both?
well, so uh, I guess if you have a number for any of the above, lay it out there.
Yeah, I guess I wouldn't want to, so I'll say the it depends answer. Let me think it through. So we've gone from 90% to 0.1, right? Like enough said, it's a huge dramatic drop. So we definitely need more. And I think we want some areas that are expressly wildlands. I do. I don't know what that percentage is, but in the wildlands and woodlands vision, for example, is suggesting 10%. I think that's fine. I don't think there's a hard rule to it. I think that we shouldn't just look at these wildlands as the only place that we're getting this benefit from. That's why I'm talking about what I'm talking about. How do we restore some of these missing parts and characteristics to our, and complement it with our other needs and management in a way that helps support, these reserves and that helps produce some of the same benefit. So I guess I would say the number really depends on, in part, what you're trying to derive out of those forests. For example, do we want wood product self-sufficiency in our region? Do we want to produce as much as we're using? If so, that's going to demand a percentage of our land that has at least some of this ecological forestry on it, hopefully all of it, that's producing wood products. And we want to balance that with, well, how much do we think we need in early successional habitat? How much do we think we need, for these other benefits? And I think we can triangulate on that. I would tell you that we're running the numbers on that publication and are suggesting that it's possible that at least in New England, we can produce the equivalent in volume to what we use if we reduce our consumption and still set aside 10% of the wildland of the land for wildland. So, I think there's a way to have our cake and eat it too. And I don't think it's a specific number. I think you sort of have to triangulate around there, whether it's 8% or 10% or even 20%. I don't know. My sense is it's somewhere in there. And I think it depends on what else you're trying to derive from that landscape or that state or that geographic region and how it complements with your other management.
Very good. And on that note, Paul, thank you so much. This was a fabulous conversation, fabulous presentation. I want to thank the participants. This is like really fun to have that interaction and engagement. So kudos to all of you. You hit 220 participants at the high. So very well done, Paul.
Great. And please, so I just want to reiterate Pete's comment. This is what drives me. So I love the conversation. I love that there are so many people engaged. I'm happy to talk more, or feel free to email me if you want publications or think of a question on your way home. Please don't ever hesitate to reach out. And I appreciate it. Thank you very much.
All right. And we'll see Paul back at 7 o'clock tonight. Thank you, Paul. Have a great afternoon.